We don't want to hear no excuses. Just jump on the plane, Bridget. Don't want to hear no.
I know, my buyer knocking me out.
Don't want to hear no.
I don't want to hear you. Really don't want to hear you.
Can't want to hear me. You can't want to hear me. 6'4". 6'4". How much time you beat Atletico for the season since Brian is a better team than Atletico?
I beat Atletico twice, some of it 3 times for the season.
Brian Munich is a better team than Atletico, right?
Yeah.
I did like today, I expected it as a something. Show your face. I tell you that, don't pay your hopes. Don't pay your hopes in the Alvajet, but I tell you that. I tell you, Alvajet, I ain't looking. I'm feeling sorry for it.
Wait. I'm going to.
Pedal so small, my foot bigger than the pedal. What I do is forensic building inspections. Right as we go in, we assess the foundation, we assess the beam columns, the overall structural integrity, try to assess the service life that is left in the building and get an idea of ballpark costing. Where did they go? Straight?
I believe so.
Oh no, this it's going up there.
They're saying about the ballpark costing.
Yeah, ballpark costing for repair procedures, right? And from there we'll determine the best way forward for the client in order to restore the building to its former glory. Right, this guy going fast, boy. This man could have slowed down, boy.
Okay.
That's him, right?
Yeah.
So we will tell him what's the idea. So you know if it's alright, let me do this section, we could go upstairs more. We could go on next level, we could come out, or you know what I mean? We could come forward.
This is your community center, this building.
Yeah. And the idea is they want to get how much space they like to do a.
We want a homework center. We want like where children can come and watch movies. We want a kitchen where we can afford to cook for the people in the community that is less fortunate and supply food at least twice a week for them. Yes. So that is what we're looking at.
Teach you a little bit, break it down for you?
Yeah.
Because I know the camera here, right?
Yeah.
So the first thing that I'm going to look at when I come to the site is the topography. So if you notice that building there, we're at a lower elevation and you could see the weep holes inside the walls, but I'm not seeing any stain marks on those weep holes, right? So you have underground water. See, the neighbor does not have guttering on the house, right? So when no guttering from that side comes down, that provides a hydrostatic force on this wall, and that water will come down and want to kick up and push up on this foundation, so it increases the corrosion and reduces the service life of this side. If you look at this side too, there's also a retaining wall here. Now that water ultimately will want to go and come down in this direction, follow the grade of the land, right? So some water from the back there will come down and start to hit that column. So we expect to see paint swelling and popping on that side, and we expect to see that whole back line there with possible mold if the soil type is cohesive, right? So this here looks, can't really see anything with this. If the soil is hard rock, right, which most likely it would be, in these areas you can't get any piles in, water will just flow through the rocks. But if it's like clay, it would stick to the clay and climb up on the walls. So given the nature of the soil type as well as the topography and then the quality of the construction, if the walls were designed properly, for instance, this is a block wall, it's not a solid cast wall, right? So because it's not solid cast, what happened, all those joints are permeable and water could get through there, and there is most likely, if we dig behind that wall, there's no French drain, which is important. So we have topography, we have soil, we have underground drainage, so there's no French drain in the back there, most likely no French drain, and I know without even really doing too much of exploration, because they have their weep holes at different heights. When we do a French drain, it usually has a pipe behind at the same elevation in the base, and that has a 2% grade, and then that connects to one coming out. So when people do weep holes like this, where it's sporadic all over the place. It just shows that there is no filter fabric on the back, there's no ballast on the back, there's no free draining material coming down. So all of that actually reduces the service life of this. Now a good indication is hard rock is because there is no slide and cracks to the front. So if you have water in the back, you would have had settlement cracks. If you have sliding to the front, there would have been horizontal cracks on this beam here to the front, especially going down to the lowest elevation. So that just goes to show that the building itself, even though of those defects, is still in good standing condition, right? In terms of surface drainage, we have water that will come down here. There seems to be... You get on camera? So, in terms of surface water, you have water coming down here, and this looks to be the catchment point, and most likely there's a crossing here, right? So therefore, this water, if the billet blocks, you have water getting in and out of different areas. But again, because it's free draining material, it's not sticking like clay. Clay is turned into a plasticine before water run through it and create an upthrust. So if you notice, there's no real... Yeah, I've seen one little crack here, but that's most likely due to poor construction. But if it was a cohesive, I would have been seeing a little bit of punch and share in this corner here. So it just proves the soil type. The drainage is minimal in terms of impact. So now really and truly, let's just go in and examine the structure in terms of if the areas have enough, cover on the steel, the quality of the construction. We're going to look at the floor slab to see if there's any warping or anything like that. If they're mopping in one area and water running down the next side, that tells us that there has been a shift, some basic stuff. So now let's go in and take a look. Alright. So this is just joint construction. This is not structural crack. It just shows it has movement in the land, but the building itself is standing. Right. This is a cantilever here, right? So the structural steel is supposed to be to the top and not to the bottom. The fact that they have no cracks on top here, it goes to show that the person who did the construction understood that the steel needed to be to the top. So that's our next good observation in terms of the quality of the contractor that we use. Right? Alright. So you see this back line here, you see all that saturation there, right? So when we walk into the base of this underside here, this will tell us if there's any mold, even if that is free draining material and not cohesive clay. There's a ponding and a percolation there. So what's going to happen is that we're going to, if you put something downstairs here in this room, like show that area there, you see all the moss and stuff, that means that that place has been underwater all the time. So therefore, most likely there's mold on this side of the house. So if in the basement, in this lower ground floor area, if it is that you want to actually put someone there, you need to have ventilation. Otherwise, it could become a health hazard in the event that they don't have enough windows or extractor fans to pull out that scent, because there is no real way to deal with this surface water here. Well, I can't take down the property to the side on top there. Most likely, you could just do a little boom on the side here. There's nothing really much we could do besides probably fix our AC, but due to the nature of the topography, that a lot of groundwater will come down here and wash. Alright? So, alright. That's all. And then you have cracks in your floor slab, minimal cracks. Alright? Minimal cracks. Minimal cracks. Alright, that's all. I'm gonna get my bearing for a second. Right? We need light. You don't want no light in here?
I forgot my light home.
We go come back in and... You spend enough time with me, you learn, you know. I'm sure you already pick up.
Yeah, I learned topography.
See, And this here is settlement. Just now. The reason why I was mashing here was to feel if any of the tiles left up through an up truss. It's not always the tile, man. Where's this at? This is a room?
Yeah. This gal plastic.
That post in the corner in the back. Oh boy. Eee, I would have liked to see that ever.
You could walk in, huh? Yeah, you could walk in.
Okay, so what going on there? Them tiles, them pop, alright? So that's the up thrust from the water in that corner there. So most likely that post in the corner they settle. So all here, you walk there. Yeah, I know walk there and there's the tile that crack. So alright, so let me take it from the outside. Alright. No, we can come back inside there and shoot. Go ahead. Alright, so you're ready for that now, right? So in terms of floor slab here, right, you could see one or two little sporadic cracking, right? But these cracks here are most likely inactive, right? So what we want to do is just V-notch and seal them up, right? Because in the event that water gets into them, I don't really expect any upthrust in a free draining material, but I expect this water that gets in here to eventually accelerate the corrosion of the steel, and then at a certain point, probably when it's nearer. So if this property was finished in 2009, it would have 50 years service life. So it is supposed to last till 2059. We're in 2026, so that's 17 years gone, right? So what would happen is that if you leave this unsealed, right, you might look as though no problem, nothing going on, but instead of 50-year service life, you're knocking off at 4 or 5 years. And if you leave it, after a while, you're gonna start to see this here start to swell and pop. As well as, I don't know if they have BRC, I don't know what else they have. Look, this is a bigger crack, right? So this is a type 2 crack, right? So this is what you call a crack gauge. Let me show you what's a crack gauge, right? So that's not a show. Right? So this is our crack gauge, right? So from point 2 down is what we call a type 1 crack repair, right? Which is basically I V-notch and I just put a non-shrink grout and I pull back and I do the surface. From point 3 to point 2, that thickness of crack there is a type 2 crack where we go and we V-notch and you inject, because most likely the crack went through and through. So this crack most likely went past the steel, whereas this crack here, you see how fine it is? You could come back in the evening and you might not even be able to see that crack, because in the evening, hot sun, the crack concrete does swell, and in the morning, concrete will contract. 4 a.m. when the concrete is cool, you come here, you measure this crack could be bigger than it is now. Alright? So the cracks expand and contract based on the temperature as well as based on the season. Alright? Now, what we want to do is also look at this here. Right? So this is concrete spalling. So this is an evidence of rust inside. So this steel here has started to swell. So what we need to do is break this out, chip this out, find the steel, clean it with Wonder, right? Wonder will clean off the steel. If we lose more than 10% of the diameter of the bar, the member needs to be replaced because it no longer structurally behaves as it was originally intended to. Or we reinforce the area, so we epoxy something in or something like that and splice, right? But this here is clear evidence of water getting up. And if you remember what we pointed out in here, this here is the wash plane. So this water definitely hit this column here, right? So we have that type of failure there. This is spalling our concrete. Now, you have two types of punching here, right? So you've seen this crack here and this crack here that emanated out. This is what you call type 1 punching chair, right? So this is a lack of top steel inside the footing and the thickness of the footing is insufficient. But is it something to really be worried too much about? I wouldn't be too worried. I'll just seal up the cracks, right? And then I'll try to deal with the water in the corner that would actually create the upthrust. And if you could watch, this crack itself starts from here. So the proximate cause is from here. And then it could be like a lack of, so BRC in a floor slab, when you have squares, right? The crack's supposed to go over the square and then go down. Why? Because the squares is like a heat grid. So the easiest place to crack is straight back down into the BRC. So I don't know if they missed out BRC or if they left it, but if they had BRC in the floor slab, it would have stopped right here, right? So it would have just encompassed the footprint of the footing, right? Now if you look at this one here now, this is almost like a circular around the column. This is why I call type 2 punching shear. Type 2 punching shear is like if I have a page and I have a pencil and I send it through, it could burst through. So this is type 2 punching shear. Sorry, type 1 punching type 1 punching shear, type 2 punching shear, and spalling, right? And all of them are evidenced by the water flow coming down. So you have water from that wall there. This one is the most because you have the most volume of water there. Now remember what we were saying, because you have the water going on, water could cause an upthrust. This column here has undergone a little bit of settlement. So this here, the columns, the beam, the floor slab is your main frame. This here is the substructure. Blocks is your substructure. Windows is your substructure. All those things. So the interface between here and here, the column has settled a little bit, but it does not seem to be active because whenever they paint, it still hasn't moved from there. Otherwise, I would have seen like a clear, like a rip in the paint or something like that, right? So this crack seems to be inactive, but all of that settlement was caused from the surcharge of the water on the upside, right? So the contractor looked like he did build it properly, but there's a lack of surface drainage on the outside, right? Now remember what we were saying, in that back wall there you would have, now water could cause an upthrust, it could cause fines to pull out and run out, or it could climb the wall and cause mold. So because of a lack of windows inside here, right, there's no ventilation, and therefore when we walk inside here and we open the door, you immediately smell the mold, right? So this here, anyone that stays down here, if you have anyone inside this for a period of time, that's going to become a respiratory issue, right? So we can't really see too much inside of here, right? But you can flash your light, bro. Right. So in this back room in the corner here, where I wanted to go, I tried to step on this here, and this tile, the tile started to pop. So what that tells me is that the water is almost like a detention pond underneath the tile there. This is not down to the tile, man. This is not down to the ground. That is the water pushing up on the tile, and it has caused the tiles to pop, and that's why it's so brittle. So everything in the back there, you know, there's basically little to no ventilation. So all the electrical looks shut, your plumbing. This is more or less, what you have here is a shell that requires ventilation, and we must do the surface drainage on the higher side in order for it to actually work. Yeah? Alright, now we could go. Alright. So let me take a look at the underside of the floor slab, right? So firstly, I want you to pay attention to the floor slab. If this is, we call this one length, this here is just a little bit longer. So it's like, it's not a square, but it's still almost a 1-to-1 ratio. So this is supposed to be a two-way slab design in terms of the steel and the construction, right? So there's no cracks on the underside, there's no deflection or anything like that. The cantilevers as well look to be in good standing condition, right? So just because it looks good from underneath doesn't mean it would be good on top, right? In terms of beam thickness, this span here is what, boy? (12 feet), right? So the span divided by 16, this beam depth thickness is sufficient. So in terms of sizing the beam, they are correct. They have the correct top steel. They just have a surcharge issue, right? So how are we going up steel? From here or there? Which one? All right. So no wall wall stiffener crack, right? So that means the person actually used, they tie the blocks. These blocks here will most likely be loaded and have the vertical steel, and there's no wall stiffener cracks. Right? Same thing here. This is most likely down to how they cut that socket there, right? Structurally good. Right. This is our wall stiffener crack, right? This here is because of the cut, the panel itself. So any additional force, watch, this here is our wall stiffener crack. Right? So you stiff, so you have had lateral forces. So what happens is on the corners, the building when it gets wind load or it wants to slide going downhill, that is why you need the wall stiffener. So your property is having some undergoing movement. Right? Wall stiffener crack. Right? All these tiles swell and pop. How they came out?
Some pop, some just.
Well, here's the thing. This is not the grout, you know. This is because the slab slightly deflect if that move forward. So you have minimal movement. Remember? So if you're putting back anything here, you have to get the floorboard, SPCS, right? And you can come with the thing joints on the end, and then you fix the expansion joints on the end, and you fix, so you cannot go back there. Alright? So this is the corner I was expecting to see the most wall stiffener crack since that wasn't falling down there and not seeing anything. Alright? Not seeing anything here. Seen a little vertical crack too, but alright. So there we go. Obviously, ceiling members itself, right? That building's supposed to be 4 feet apart. They're looking more than 4 feet apart. My eye blind. And that building, that definitely more than 4 feet apart. They're like 5 feet. Yeah. If not more, right? So the buildings are. So therefore, if you ever have a hurricane from uplift, then you have a problem there. But you're in a downslope in a valley, so don't worry about that. Right? But if you was on top of the hill, like where that guy is, and he more suspected wind load, that would have been a problem. Right? 4-inch beam. Okay. How they tie it, anything, right? And you see what they do here now. You see how that ring beam is so high, that ring beam not supposed to be so high. So what's going on now is that one, when you basically block almost straight up to the beam. So now you can show back the beam. Because what will happen now is that when air tries to get out and go to the undervent beyond this beam there, right, it can't really escape. It had to hit the beam, go up, and then things. So underneath here, go bake, right? So your air conditioner inside of here, the electricity bill gonna be ridiculous, right? So there's no insulation, right? No insulation sheeting, and then on top of that, this ring beam should have been here. So the location of it itself is really and truly not in the best spot, right? I've seen we have some electrical PVC and stuff, but I don't really pretend to be an electrician, so. Right. Right. So we take out any corners. Nothing in this corner. So as I walk, you can hear the tiles. You hear the tiles on the pickup. So you do have some slab deflection. There's nothing in this corner as well. Unless they paint over this. That look like a paint over that? Or that just look like... That not looking like a crack. That just... However, they plastered it. Right? So surprisingly... to really hear anything inside. Right, and again there's a lack of windows for ventilation. There's a little here, like vertical crack here in the area where the walls meet, wall stiffener again. So just some underlying movement, right? So windows, ventilation, drainage, right? Okay, definite wall stiffener crack there too. Alright, so I think we have a good idea as to what is the damage level. So there's no type 3 cracks, right? There are very few type 2 cracks. The areas with the cracks to repair is not that much. The problems that we have is that to solve the drainage issues and the water coming on is more expensive than anything. Because if we just repair the cracks, it's just going to come back. Yeah, it's been in top in mud. Right, so really and truly this property should have set back from the retaining wall at least like a 5 feet corridor. And what they should have done is on the back foundation, you see, in rock water there's duct underneath the rock, right? So what they should have done is the foundation itself, they should have oiled it and put the plastic on it, not like a French drain, where water would have hit the plastic and then run on the plastic and you could have carried that out, right? So you could have put a pipe, so it's like a French drain, but that is what would have saved this entire property. And within that small corridor to the back there, we will go down and take a look. That will be manual labor. You can't fit an excavator inside of there. So that will send up your cost. So we have structural things to do, and then we have aesthetic things to do. You have windows. Once you repair and you deal with that water, you don't need to underpin the front or anything like that. You just take care of your drainage. You do type 1 and type 2 crack repairs, which is basic. And from there, it's just more of finishing touch, you know, that you want to do. The structure is still good. I would say damage level probably over 15%. Once a building cross 40%, that's when the cost to repair is actually more than the cost to rebuild. So the trick is, the real repair cost is let's go behind the property and see how that water falling and how we could deal with that, right? Yeah. Oh, General. Yeah, right there. That's the problem. Hey, boy. I don't like full of stuff. Then I like break my. Yeah.
Right there, easiest spot right there.
Nah, I even.
Walk up a little bit this side. Okay, so this is the problem area here. This is very important here, right? So there is clay inside of here, but you could see the guaraca inside of here too, right? So this is boulders, but guaraca doesn't deal well with water. So you do have an upthrust, you do have some cohesiveness, but what has happened when you have boulders and soil, and where boulder meet boulder, those are the pockets that water could stay and saturate and stay underneath the house before it finds its way to outfall. So if your outfall is blocked lower down, like it can't flow to somewhere, that's when it is back up. So we had to walk down on that side of the property after to see where the possible sources of outfall is and make sure it's not concrete. Because if it's concrete, the water can't evaporate, it can't, roots can't drink it, grass can't drink it. So the water will stay and then it will continue under more concrete causing more sinkholes and collection points before it finds somewhere that is actually grass. Right? Hey. Alright, so this is our drop down here, right? Alright. So we have 2 retaining walls. Alright? So watch this here, right? I don't know if you're getting, right? But basically what they needed to do when they were building is this soil behind this retaining wall was supposed to be thick plaster behind the wall, 3 coats of oil, come back and run on the same retaining wall in this direction here. Then you needed to do the ballast on the wall with the French drain pipe. Right now, all your surface water just running up against this, right? And then it hitting this like a baffle wall, dropping down, and then it's pushing underneath the foundation, and then eventually making its way out to the outfall. So really and truly, your work on this property is more this backside here. So you need to clean out behind this back here. You need to actually, if they did just leave a little setback from the retaining wall, boy, oh god. Alright? So what they needed to, so what we had to do now is dig out this soil, go straight down to the footing, which basically very expensive, very hard material, no equipment, and waterproof the entire thing. Or if the cost is exceeding the return, just leave the downstairs, break out the walls, leave it open, let the vent flow and let it take moisture. But then here now, you do whatever you need to do on the top, right? And what we could possibly do on the inside is probably come in the back wall and drill some horizontal shafts inside the wall, almost like pins, right, with PVC, wrap it in filter fabric and put the ballast inside of there, and then have it come and collect on our back drain to the outside, which would be much cheaper, less effective, but it will reduce the outfall on this whole thing. And also that will weaken the structure too, because you're going into a hole in back soil, you know, but this soil itself is rock. It will stand on its own. So this wall here is more or less just formwork, collecting moisture. And that's it. Alright, so they go down to the outfall now. Now what happened? I fall off scaffolding now, man. And since then, my mind just
Play games with you.
The measuring for I believe.
There I go.
Yeah.
Right. That's all. We take a look at this column on here. Now you see all these drip lines here? All those things need to correct and run to outfall. Right. So your backline is your problem. To be honest, right? What you could do, condemn your walls from this backline here, but from this post here, if this is a post, right? You could have your walls inside of there. Come forward, because then now this have the corridor for it to breathe, you know, and then we have the utility access to deal with the water. That's it. Right? So we'll just go down and see. Alright, so the lower side of the property. Alright, so you see this is subsidence. See how there's a drop on our break? That's how our subsidence crack is up. Right, so basically a whole property you want to outfall there. So what's going on is that water meeting this block wall here, right? Some can come through the joints, the vertical, the mortar joints, whatever. It will duck down and it will run out to right here, right? So let me see if we have grass or it's more concrete. It looks like it's more concrete. So it's just more concrete and they don't even have grass down there to drink it. So really and truly, your best, and you carry, yeah, the best thing to do boy is just catch the water before you damage your property, because you have some damage to your columns. Alright, so repair cost in terms of structural cracks and stuff like that, a bag of render rock and SCL is what? About 380? About 380 Nitobon. So a Nitobon for one bag of render rock, I would say you would spend about 10,000 in material and probably about 10 in labor, right? In terms of like a contractor that actually know what to do. But I could show you how to do type 1 crack repairs, which is what I recommend for there. Then you could get a drill that could burst through the back of the wall. We want it on 1/3 the height, right? And we will perforate a schedule 40 pipe, just probably 4 feet into the thing, pull it out, and you just send it in every 5 feet apart, and then so that we making weep holes basically, right? And then you hook up like a T on it, right? Now that pipe wrapped in filter fabric. We have tie straps every 12 inches, so I would say that's about 20,000 in material and about 15,000 in labor, right? So what figure we at there? 20, 40 plus 15, like 55k. But honestly, I would take down the back walls and just leave these front walls here. It had no saving that in the back there because the surcharge will come back up. But if you still want to have some rooms downstairs, just leave it off the corridor from that second column come up, right? So there is restoration to do in terms of your finishes, your block wall, your electrical, your plumbing. I can't really speak for your electrical and plumbing, but if we go, your ceiling definitely needs to be done. There's no insulation, there's no gutter and down pipe to bring that water down, right? So that water just dripping from there, and that will fall, and that will probably most likely be the culprit to spoil the thing. On top of that, there's termites here, so they get into cracks and they live in water, right? So therefore they will go in and make your cracks wider and stuff like that. So by the time you're done, refurnish, refit this whole building, you might be spending about $300,000-$400,000. So you might spend about 50k in structural cracks and repairs and the little French drain through the back of the wall. You don't even want to entertain the cost to dig out the backfill in the back. And think that is better. You just break down the structure and build over with that cost, right? So what you want to do, and then after that, you're gonna get like no tiles, SPCS flooring. This floor slab is still good even though it warped, but that's because of the movement. Once we deal with those things, because what happens, right? If this, watch this here, right? This is punching chair again. The circular punching chair is two-way punching chair, and the punching chair that comes out from here and here could either be like a lack in thickness of the footing or the steel insufficient. But what most likely happen is that the fines from underneath this column has washed out, so therefore it's sitting on less. So therefore, if you deal with our water now, you should be okay, right? So in terms of tiling and your repairs for your windows and opening up windows and stuff like that and doors, you might need a general contractor to come in and give you that. But in terms of structural repairs, probably about 20, probably about 50k, right? Don't even think about doing that behind there, right? You definitely need a sealing man to come in. I would say probably like $300 a square foot, probably $400 a square foot would bring this house back to wherever it is. But that will carry your costs. All those finishes is what expensive. So you're looking, I would say, $400,000 to $500,000 at the end, because I have a lot of things to do, and that's it. And also, I can't repair. This here is a true and true crack, right? What a crack is an expression of the stress experienced by the foundation. I cannot dig into the foundation and seal the crack in the foundation. One, I wouldn't be able to find it, and then two, it might be so fine we can't see it. Right? So you can't repair the crack in the foundation. So all you can really do is seal these cracks, and what we're going to do is crack monitoring, because if you seal this and you open it back, if you seal it and it opens back, it's active. So therefore, you'd still have some surcharge, right? So if it is that it still has surcharge, you had 17 years. You know, if this continues like this, it probably have about another 15 to 20 years untouched. Alright? But if you do what I suggest to you to do, you might get 20, 25 years easy, but comfortable. You know, so that's what you're looking at. Alright? So that's it. Yeah? You want to do engineering, bro?
Actually went to school to do engineering, software engineering, but
If you ever going to buy a piece of land, let me check the land before you buy it.
you said I'm going to call now to get a contract.
But you understand everything,
Yeah,
right?
I understand what you're saying.
So it's soil, it's drainage, it's topography, it's the quality, there's the design, the thickness, the steel. Top steel, right? Record this, right? So top steel in a foot. So when a contractor building, you go always see the bottom cage like that, right? Now the bottom cage deals with the weight, alright? But top steel deals with lateral forces, which is sliding due to the topography. Lateral forces from the washout of the soil, where the soil, like this water washing out, I want to pull the footing this way, alright? And the top steel also deals with the punch and share where the column wants to punch through and like break the paper upward like that, alright? So right now, if you go inside this footing, it won't be flat. It can be convex like this, alright? So inside of that now, it is no longer behaving the way it was designed for, and that reduces the overall service life. So just by seeing this here, I know with a 90% chance there's most likely no top steel in the footing, and this column here has the most amount of sliding forces because the whole building want to slide to come down to this corner, because the washes on this side, the slope. If I stand on top of a hill, I can want to fall over. It's the same thing with a building. The angle is gentle, but still, this there have no kind of angle compared to this for this post, right? So this post is more load bearing than anything, and this here is sliding, is up truss. Oh, and top steel also deals with up truss. So the column in the back on the right hand side needed to have top steel. This column here could have just had bottom steel and would have been perfectly fine. So with all those things considered, that's your ballpark and that's your assessment that you're looking at.
What exactly is topography you're saying?
Topography is the slope of the land, the gradient.
Okay.
So flat land, you would have more, well, flat land, you wouldn't really have sliding forces. But flat land has the challenges in drainage because it's kind of like the valley, and water that's collected and the water. If you want to, for instance, right, as we see the soil there, you're seeing the rock meeting the clay. That clay could have wash out and just leave grooves between the rock and cause a sinkhole and pull soil from random spots underneath your house in hard rock. But in the event of is a clay, it would push, but first it would swell the soil up by 2%, pushing up the footing, and then in the dry season it would go down back to its natural and then shrink by -1%. So your footing is up down in the rainy season to dry season, and what's going to happen, you're going to swell up and push up, and that the footing is meant to be a fixed member. It's not a shocks in a car. The top steel deals with the up truss, right? But this is hard rock. There's no up truss unless you have obvious drainage issues. So if they were building over this building, they would have shifted the building about 5 feet to the front first, because that's what we call perimeter wetting. Where the water is getting in, it will wet those edges. And that's where you would get your up truss, even if it's hard rock. And we did see some clay inside of the profile. So the design is a little not that functional from a structural drainage perspective. They just try to jam it to get the most space in order to get the most yard space. I understand that. But if they wanted to do that, they were supposed to do the necessary mechanism behind the retaining wall, so you could have done what they did there. And that's it. So those things, and you have a potential repair cost. But really and truly, you need the general contractors to come in and the ceiling. So in terms of the roof, you need someone to come in and do insulation. Right? The beams look okay. The purlins are spaced too far apart, but you're in the valley, so the wind load won't really affect you. You're honestly, just installing guttering on your neighbor house upstairs, up on the hills there, actually reduces your surcharge on your house, on this building here, literally. So I know your neighbor wouldn't want to do that, but that's a serious thing to to consider. Right? Your ceiling itself, do not put gypsum, put drop ceiling, which have the squares, and you could push up the panels because that could take movement, so it won't crack like your wall stiffener. Right? So, and then your flooring itself, SBCS, don't use tile. So you can't bring in you can't tell the man, you can't bring in a man to tile. You have to get a costing for SBCS flooring. You have to get a costing for drop ceiling. You have to get a costing for the insulation back. Somehow you have to take down that ring beam, right? Or we just figure out a way to install vents. How they install a ring beam there is you're going to be real hot, right? So you could either accept the hotness, the heat, or break the ring beam, break 2 layers of block, and then build that back. But that cost is that not making sense, right? So you just have to accept that the building going to be hot upstairs in the day, right? So if the community coming together in the night, it's cool. Yeah. You need nothing to worry about. So leave the ring beam where it is, or you could raise the roof. But that too and all this cost. So just leave it as this, right? You see, you want the soffit to be on the same, at the top of the ring beam. So therefore the hot air just goes out right there and thing. That's them going to boil inside of it. Right? So that's your roof, that's your flooring, you have your crack repairs, and you know how to basically what you call it, monitor your cracks. If you repair it and it open back, well, we still have something to do. So you see, the thing is, this is a visual non-destructive inspection. I'm not bursting this here to see that this steel swelling and popping here, right? Look at this paint here. The reason why this paint is swelling out is not because somebody pressure wash and burst there. That's the moisture climbing, that's moisture wick, right? And this is very little place. So for this to moisture wick here, that's real water, right? And your culprit is up in that corner down there, right? So all those AC vents and things that drip in, all those things, all your gutter and pipe and all of that needs to be redone. You might look at a comfortable $500,000 here, easy, right? See the termite running down there, termite proofing around this property alone, it will not be as effective because the termite proof now, inside the foundation, when you dig the trench, that is when you're supposed to termite proof. Because if I termite proof outside here, right, the termites could duck underneath that. Termite just come from miles underneath and get directly underneath my footing and skip the barrier. Yes, it's a deterrent, but they love moisture, right? And once you have cracks and stuff like that, you have space for them to move. And that's it. So, So, you want to know good news or the bad news?
I want to know the good news. I don't like bad news. I don't take it easy.
Okay, so good news about 400 to 500K should bring back your property within good standing condition. Bad news is that the real correction cannot be done because that was supposed to be done at the construction stage. Behind this wall here, they were supposed to thick plaster, the 2 retaining walls on the back. All your problems is from water coming down. So you do have some spalling cracks, some punching chair, and another type of punch. It's just water, right? And it reducing the service life and causing the building to protect. So all your tiles that pop and stuff inside of there. So your property has undergone differential settlement. Even if it's like a 1 millimeter difference in the column, a tile is not a tile is a brittle member. It's not like a wood flooring expansion joint. So if one column drop, the floor slab ring, the wall stiffener ring, and the ring beam itself ring, right? So that is why you cannot put gypsum ceiling up here. You have to use drop ceiling, which is the squares on the panels, so you could always push up, you could take movement. You cannot put tiles back on top there. You need to put SPC flooring, right? This corner in the back here, it has so much water that we can't really correct the drainage from your neighbors. Like, for instance, they don't have no guttering. The people on that side, they have no guttering. And then in natural topography, the underground surcharge will run underneath the house, right? So you can't, what we had to do in that back wall there, honestly, I would have just break off from this back up here and leave that out for you to breathe and build a wall back there because water will always upthrust on that. Alright? What you could do, it will weaken the wall, right? But you could come, pretend this is the back wall in the house, right? He could get a drill, right? And he could come in here, right? at the same height, but 2% grade. So wherever your outfall is, they're lower, right? So if you start on that corner there, you come down and you're outfalling. Yeah. Now, actually no, we can't. Yeah, okay. So what he's going to do, he's going to send in a pipe for about probably 5 feet, right? And he's going to schedule 40 pipe, perforated, right? Wrapped in filter fabric, 1 feet lap length. So the filter fabric goes around and laps by a 1 feet. You have tie straps on it every 12 inches and it's filled with ballast, right? And what I'm going to do is collect some water, but this is free draining material already. So it's not even really that effective. When they were building the wall, they were supposed to put the thick plaster in, 3 coats of oil, stick the polythene, and then put that same pipe in the back on the line. So all the water would have hit, all your water hitting right now, hitting the wall, like a buffer wall, it dropping down on top of the footing, and then it making its way under, and finding its way to the ultimate low point. And that is why you see most of your property damage in that far left corner there. We can't go back and correct that, we can't dig out all of that. So your structural repairs is probably about 40 to 50,000, with most of it really and truly trying to relieve the surcharge. But I seriously recommend, if you put anyone in the bottom here, they will get respiratory problems. It will be mold. That's why when you open there and you walk in, regardless of whether they close up or not, even if you have windows in the back there, ask him, when I walk in, you just hear the tile go crack. Because
I know what you're saying, it happened to me. Right now, my tiles in my gallery, crack up, so I had to rip out all because the water was going on.
right. But what people miss is, aside from the cracking, you have ongoing corrosion, right? And steel don't really, steel is like this, right? It don't really, this is 1, 2, 3, 4, 20, 30, 40 years, like that. It's break like a bottle. It gets stretch first and then break like glass, right? So you right now, when the steel loses its strength from the corrosion, your house, just now you can walk and you can see the underside of, if it's a suspended floor slab, you can see the concrete start to break off and drop underneath, and you can start to see the steel swell and pop. Right. So that service life is gone. That is no longer safe to stay in, right? But this is not a government project, right? We understand that. But if it is that you're planning 50 years there, it ain't going to happen, right? So you need to take care of the uphill water. But even so, you have most likely lost more than 10% of the diameter of the back. So really and truly, it is actually cheaper to break down and build over than actually trying to repair. And when you try to repair, you're doing patches on stuff that once a column and a beam is no longer at 90 degrees. If I do repairs all over the place, it no longer sending the load down to the footing as the original design, and your building not going to behave in a way that we could clearly assume how it would behave. We won't have a clear picture, so we just would be working in the dark and spending money in a hole, you know. So all these buildings here, well beyond service life. This is a serious problem, and I watching. The only thing this country have is these people trying to give container homes. I work with both P&M and UNC, right? I'm actually closer with the P&M. Then there is serious failure, but they don't care because it does not do anything. It does not hurt them. You drive on their roads. I just do inspections. I went up top of Maraval Hill by this man with the throw drain water on. What's his name? Hines. Right? I go up by, if you see, I watching the land next door to do a house. If you see his house, I make good money. I can't build that. Right? I cannot build that. These men them live on top and then come down and try to papi show all the way down. That's what they do. So you can spend about 500k here, but you can come back good and just leave that corridor out there. And before you buy a piece of land again, I just go down Donald Hill. I just go everywhere. I don't care if I'm Indian. Just you give me a call, and if you have something to check out, I will check it out. Yeah, man. Don't worry, the payment is not come out of charity. You know, so you know.